Can I have your attention, please? Good evening, everybody. Good evening, ladies and gentlemen, and welcome to today's keynote lecture, whether you are joining us here in person or following up with us remotely. I hope you have been having a great and enriching time these past few days. My name is Ammar Abu Saoud. I'm a PhD candidate in chemical engineering working on water desalination with Professor Ziping Lai at the Advanced Membranes and Porous Materials Center. WEP is an inspiring 2 weeks filled with stimulating talks, lectures, and workshops from prominent experts. It offers a distinct opportunity to learn about emerging and ground-shifting topics. Arguably, one of the hottest topics globally today is artificial intelligence. Its benefits are virtually endless, its applications are limitless in every field imaginable, and its impact is too great to be ignored. As the world is being captivated by AI, however, many are increasingly concerned about employment, safety, security, privacy, as well as many other aspects surrounding this new technology. Intel's Director of Human and AI Systems, Lama Nachman, is here today to point out the benefits of collaborating with AI instead of fearing it and competing with it. Today's talk will be 30 minutes long, followed by 15 minutes of Q&A. I hope you enjoy it. And please join me in welcoming the moderator of the talk, Professor Nazik Al-Atab.
Thank you very much. So good evening, everyone, and welcome to the Building 20 auditorium for tonight's keynote lecture. I hope that everyone is enjoying so far the very exciting WEP program. And now it gives me great pleasure to introduce Dr. Lama Nachman, who will be giving a very interesting talk about AI and how we should change the narrative from AI-human competition to AI-human collaboration. So my name is Nazik Atab, and I'm an assistant professor of electrical and computer engineering here at KAUST. And now I would like to formally introduce Dr. Lama Nachman. Dr. Nachman is an Intel Fellow and Director of Human and AI Systems in Intel Labs, based in California in the US. Her research is focused on amplifying human potential with AI through responsible human-AI teaming. She leads a multidisciplinary team of researchers that explore new user experiences, sensing systems, algorithms, and applications, and transfer these capabilities to business units to impact future Intel products. Dr. Lama has 26 years of experience in the areas of context-aware computing, human AI systems, multimodal interactions, sensor networks, computer architectures, embedded systems, and wireless technologies. One of the most notable achievements of Dr. Nachman's career is an Intel collaboration with Professor Stephen Hawking. In fact, in 2012, she led a team of researchers who developed a new software, platform, and sensing system to help Hawking communicate. Subsequently, she also led the effort to take the technology to the open source community, enabling people with disabilities worldwide to communicate using limited input and live as independently as possible. Tonight, Dr. Nachman will deliver a very interesting and timely keynote entitled Changing the Narrative from Human-AI Competition to Human-AI Collaboration. So without any further ado, I would like to welcome to KAUST Dr. Lama Nachman, and the floor is yours, Dr. Lama.
Thank you so much. Thank you for the kind introduction. I'm really excited about being here. I was actually here last time in 2011, and I'm absolutely amazed by the progress that I see from that time. It's really quite inspiring to see what a grand vision coupled with all of this amazing talent can actually change. So I'm really hoping that this might lead to some further collaboration. So I will try to stick to time talking about human-AI collaboration. It's actually a topic that's dear to my heart. And actually, in the presentation this morning, Dr. Makki was actually talking about all of the amazing innovation and progression in AI that we have seen over the last 2 decades. And in fact, if I reflect back on the first half of the last decade, there was so much excitement about where AI was headed, right? We started to see amazing progression because of actually deep learning and seeing results that were actually overtaking human recognition capability in some of the specific areas. And because of large data sets and amazing computing capabilities that we were seeing, and some innovation on the algorithmic level. And what is interesting is that there was this euphoria in some sense that this is great, and a lot of that progression is going to happen, and companies were really leading amazing progression there, and academia was proving out just one result after the other, and especially starting to really make its way into a lot of interesting fields at the intersection of AI and all sorts of other fields. And then what started to really happen in the second half of the last decade is that we started to see a lot of concerns that were actually starting to bubble up, right? So there were tons of stories that were coming up in the news. We started to see a lot of issues with things like privacy, worry about human labor, really major sustainability concerns, and so on. So in some sense, and actually out of this morning's presentation, one of the things that we really have to be thinking about is what is a different way, right? So, Dr. Makki in the presentation this morning talked about tons of actually interesting challenges to be pursued. And, in the way that I actually think about this topic, there are also other methods that we really need to be thinking about, and especially if you start to think about the human being one of the most intelligent agents in the world, then how can we actually leverage the human in these systems to actually change the way that we're actually coming up with solutions to the problem? So if you assume that human intelligence is a core piece of that collaborative system, what would the type of solutions that you actually start to build, and what type of AI capabilities do you need to actually make happen? And that's not to say that that would replace anything else in terms of automation and autonomous systems, but it's actually for many problems that we today see a barrier towards the deployment of AI in these areas. There is actually kind of an interesting approach to start to think about human-AI collaboration. And that's really kind of, if you think about it, it's kind of sensible for different reasons, right? So if you think about what AI is really good at and what humans are good at, these are actually quite complementary, right? So AI systems are fantastic at processing large amounts of data, high-dimensional data, finding like the needle in the haystack, and all things that actually humans are terrible at, right? But if I actually look at humans, they're really good at learning from very limited data, learning things that they can apply to totally novel situations and environments that they've never seen before, and being able to make decisions in highly ambiguous situations. So when you actually think about those complementary capabilities, it makes perfect sense to start to think about, well, if I had both, how would we actually improve outcomes in all sorts of different domains? So As Nazak mentioned in the introduction, I actually run a multidisciplinary team, and that team spans social science, design, and AI. So what we actually start with is always a human-centered approach, right? So we have social scientists that go out into the world, discover all sorts of interesting problems, and then start to think about what does that look like in the context of a human AI systems, and how can we actually improve outcomes in these different domains. So, being at Intel, clearly manufacturing is one of the domains that we look at, especially that we essentially have a playground that we can go and get tons of data and interesting use cases and do a lot of the work there. But we also do a lot of work in education and work in assistive computing for disabilities. So what I'm going to try to do here is go over some examples in these different domains and kind of try to get across that message of where do we see some of the opportunities of doing things perhaps differently, and what would that look like if we start to really design with the human in the loop from the get-go. So let me start with manufacturing. So what's interesting in manufacturing is that if you actually think about many manufacturing facilities, and Intel fabs are just one example of those, despite the fact that we have tons of automation in these different settings, you still actually see humans. Like, you walk in, and there are actually people. And these people are performing very complex tasks, whether it's maintaining systems or configuring things or trying to fix problems that are happening or diagnose issues or whatever. And typically, the problem that we see time and time again is that there are errors that happen, and in many cases, yes, humans end up being the source of that error. So one of the questions that we were asking is, is it possible to actually build a smart task space that can start to watch people as they perform these tasks? And these are tasks that have very specific procedures associated with them, right? This is not just open-ended things. There are actually manuals and procedures and things like that. So can actually an AI system learn what these tasks are supposed to look like? And can it start to support people as they perform these tasks, answer questions, flag errors, enable human learning, things like that? The problem, of course, if you wanted to actually do this in a traditional way, well, how are you going to get an AI system to actually learn that, right? And how is it going to continue to learn every time you go from task A to task B, and every task in a manufacturing environment continues to get edited and changed? So the amount of effort, if you wanted to go and train all of these and label all of these and then continue to train them, is really not sustainable, right? Now, if you're able, however, to actually do that, there are tons of different tasks that you can apply that to, right? So if you're able to actually figure out how to kind of get to the nugget of building such a system and make such a system learn over time from the end user, who happens to be the human in the loop, then you could actually enable such an evolution more naturally. And if you're able to do this, then there's a lot of benefit, right? I mean, there's benefit in supporting the person who's performing the task, in supporting the learning of that person, but also there are benefits in terms of being able to run these type of spaces, right? Because then you will have much more observability about what type of problems are happening, what type of steps in a manufacturing procedure are more error-prone, which are those will translate into downstream problems and things like that. So essentially, what we were really trying to do is think through how would you go and start with all of this knowledge, which already exists, right? These things are in manuals, there are steps, there are procedures within those. Can you actually start by ingesting all of this information? And then as people start to perform these tasks, this is in the training cycle, with simple think aloud type systems, right? If the user is actually providing, comments as they're actually doing it, without actually trying to label frame by frame and do all of that, but as you're actually doing the procedure, can you be talking about it in a way that enables then, we're extracting from what those procedures, all of these, semantic roles and figuring out what the actions and the sub-actions need to be. And then we're trying to align that with what we're seeing visually from actually being able to then build an action recognition system. And then once you're actually doing that, the nice thing about having actually a dialogue system that you're building with the same type of capability is that then you can use the dialogue system to go and ask the user as you're training the system about things that you're actually confused about. And over time, what you do is you get actually better at improving the capability of this action recognition system and of that dialogue system. And that system can then support the need of the user. Now, this is interesting, and that kind of fits within the examples of things that happen in smart and ambient environments. But there's also kind of a similar thing when you start to think about the notion of robots and embodied AI, right? So, I mean, we've seen tons of automation and robotics in all sorts of fields, and in manufacturing for sure. However, those tend to be in places where there is high volume manufacturing, right? Because then what you're doing is you're amortizing the cost of training and programming these robotic systems to these really high volume tasks, and then typically tend to be in a constrained environment and things that don't change a lot over time. Now, there's a huge set of opportunities for really small volume, very mixed type activities that need to happen that today don't typically utilize robotics. So if you start to think about what does that mean from a human-robot collaboration perspective, right? There are actually multiple aspects where you think about human-robot collaboration. One is actually how do you train the robot, right? So if you think about programming by demonstration, you can start to think about how do you develop all of these different primitives that are able to actually, from a perception system, start to kind of capture the different tasks that the human demonstrator is actually doing and break down that into these different primitives that then allow, essentially, the user, which in this case becomes the programmer, to be able to understand what the system has learned and continue to edit and modify over time. Because the problem is, if you think about it, if you go from this notion that there is a dedicated robotics programmer to there is a user who understands the subject matter, in the field that they're doing, then you need to not only enable them to program the system, but to understand what the system has learned and have enough transparency in that system so that that person can actually edit it. Now, what's interesting is that there are a lot of different aspects and complexities in the way that you would need to do that, right? I mean, there's a lot of work in trying to actually make things like robot dynamics and being able to understand human pose and hand pose and all of the motion planning to actually happen in real time, being able to actually react and change both algorithmically and in the way that it can actually execute that in real time. There's also an interesting thing when you start to think about, well, can you actually, I mean, in the first video, I don't know if you've noticed this, but that was actually a motion capture system, right? And here, what we've been really trying to do is actually, if you want to democratize this further, it's very hard to go set up a motion capture system, right? So can you actually do that from off the shelf, like a real sense device, for example, which is what I'm showing in this video, to actually be able to do that? And furthermore, if you actually want to train people to be able to do this over time, then you probably want them to actually get the hang of this and do that without necessarily having to have an actual robot in place while they're actually learning to use that system. So that's when having a digital twin actually comes in really helpful. So this is just one example of an actual application that we ended up actually doing where this is actually Loihi chip, which is a neuromorphic chip that Intel Labs has actually built. And what you could see here is actually the robot is being programmed to actually do that validation process. And you can see this is not something necessarily at a volume that you can support complex programming, and it won't scale if you do that. But being able to enable the end user to do that makes a huge difference. Okay, so that's if you think about it from the perspective of programming by demonstration and how do we get the robot to do what we want it to do. Now, the second piece of this puzzle, if you actually think about collaboration, when humans collaborate, they tend to actually have some sense of what the other person is doing when they're actually trying to do, a task together. So one of the things that are interesting here, and this is, again, a toy example of just packing these different blocks into that box, and one thing that you probably notice when you look at this in slow motion is that as Javier is actually trying to reach into that block, the robot is almost like reaching into that same area, and because of collision avoidance, it actually tries to move away from him, right? But if you think about it, that's not really how humans and humans collaborate, right? There are a lot of different things that we cue on. We can see where somebody's reaching. We can anticipate what somebody might be doing. We can look at where they're gazing. There are a lot of signals that we give as humans that are actually interesting to cue off on. So one of the areas that are actually quite interesting is to start to think about how would you understand the physical intent of the user. And in this specific case, what we're actually trying to show is you could start to see the probability maps as Javier is actually moving his hand and looking at that trajectory, but also looking at the body posture and where he's gazing to try to get a sense of that. And then as a result, in this specific case, the robot is actually making sure that it's reaching into a different space. But if this was actually a collaborative task where they're not trying to do independent things together, but they're actually trying to help each other, you could actually then also utilize that for the exact same reason. Okay, so that's an example, a few examples in manufacturing where some of the areas that we think about when we think of human AI collaboration. Let me shift gears and talk about assistive computing for disabilities. And maybe let me just set a little bit of context on this work. So this work has started back in 2011, and this was actually to enable Professor Stephen Hawking to communicate. So when he got in contact with us, he had been using an outdated system for quite some time, and over time, initially he could actually move his hand to control what he wanted to actually trigger, to pick letters out of a screen, or to pick options, or to move a mouse or something like that. And then, of course, over time, he lost his ability to be able to do that. So he was looking for a solution that can help him. Now, what's interesting is that if you think about a Windows machine or any graphical user interface, we kind of take for granted that it's intuitive, but there's an assumption that somebody can actually move a mouse, which clearly isn't at all an effective way of interacting with a machine if you can't actually move the mouse. Because the equivalent of trying to scan a 2D grid to get to a point versus selecting an option off of a menu, for example, is actually much worse from a time perspective. Now, add to it the amount of errors that people make as they start to lose their ability to control things at a finer level. So one of the things that we did is we essentially started to think about this as a complete end-to-end system, and what are the things that are possible within the constraints that he had, right? So we were totally constrained by not actually changing the look and feel of the user interface. But then we could change anything else. So there were a couple of things that we were looking at. One was, I don't know if you can actually see this, but if you look at his face, there is just under his glasses, a black thing that extends there. That is actually a proximity sensor that is able to pick up his cheek movement. And so essentially, you can think of it as him clicking the mouse or clicking a button with his cheek. So every time he moved his cheek, you're able to actually detect that he actually did that. And then coupled with an interface that changes and goes through different selections on the screen, you can actually when you get to the thing that you're interested in, he moves his cheek, that gets detected, it activates what he's trying to do. Now, what's interesting about this is, one part of this puzzle is to actually improve the sensing to a point where it's actually being able to adapt to a very changing environment, right? Because, day versus evening, one day after the other, his ability to move his cheek in terms of speed and magnitude and all of that changes dramatically. I mean, he doesn't have great control over it. But then the second and bigger piece of the puzzle is essentially changing that interface to not be so dependent on, it can be anything that he can choose. But if you start to actually use, some prediction of, what he's doing and the context of use, then you're able to start to anticipate what he might want, and you can turn that into a selection of a few things, and which really dramatically increases the time. And just, I know this would be actually mind-boggling, but, when we started, and mind you, Professor Hawking didn't just use his machine for communicating, right? He used his machine to actually give lectures, to write books, to surf the web, to do everything that we do with our machines. So as a point of reference, which kind of totally shocked me when I saw it the first time, for him to open a file, it took him 4 minutes. Now, just think about this for a second. Just imagine that it took you 4 minutes to actually open a file, and how many times you actually do this in a day. So being able to actually improve this, right, for him, that meant going from 4 minutes to less than 10 seconds to actually do that same function. So it's really about utilizing a lot of contextual awareness and being able to adapt that system over time based on language models that understand his context of use and change the prediction accordingly. Now, what's interesting is that, as we took this, to open source, a big part of this was really trying to decouple the sensing piece from, all of the software platform that we're actually able to do, which really meant that, you can transform any type of movement that a person can do into a trigger signal, and then that trigger signal can then be mapped into the same interface. So you don't have to redo anything if somebody can move an eyebrow or do something else, and you use a totally different sensor to enable that to happen. Now, actually, earlier in the presentation this morning, there was some discussion about BCI, and this is really so everything that I talked about assumed that somebody actually is able to move a muscle. But if you can't move any muscle, then what do you do? And that's when BCI becomes actually really interesting. So here, what you're really trying to do is essentially utilize EEG signals to try to predict what a person has in mind by them focusing on a choice out of a set of choices. And what's interesting there is that, a lot of the focus is to try to enable this to be accessible to everybody, right? So you don't want the $20,000 headset that allows that to happen, but you actually want an open BCI solution, perhaps, that's a few $100s that you can actually turn with adding a lot of machine learning capabilities and enabling more word prediction and language models to get fused with the EEG signal to actually get you there. Now, all of that assumes that the basis of that interaction is about letters and words, right? But we've seen amazing progress in things like response generation. And we talked this morning about ChatGPT being actually an amazing tool and a capability. Now, if you start to actually then think about, well, what is kind of the next place that you would go? Now, imagine, even with the best of advancement that we were able to do for Professor Hawking, at the end of the day, somebody said something to him, and he had to go put together letters and words and all of that, and then there was a long silence gap, and eventually something got spoken, right? So you need to really close that silence gap. And one really compelling way of doing that is to actually have the system predict at the higher level, not at the letter level, but actually at what would this person want to say. So starting to think about how do you use things like response generation capabilities to do that, but not really use it in the way that it was intended, meaning an autonomous agent, but actually innate, because that's not what we're trying to do, right? We're not trying to replace the human. We're trying to enable the human to actually pivot that response generator, which is trained on billions of utterances, to the few utterances that matter to this person. And that's a big part of that challenge in that space. So one last thing that I want to talk about, because I mentioned education, is actually specifically looking at early childhood learning when we think about education. And again, through a lot of the early ethnographic research with students, with teachers, with parents, one of the things that we've realized is that parents have this dilemma. On one hand, they want to be able to utilize the best that technology can offer to personalize their kids' education. On the other hand, they're totally terrified of screen time. And we were told this time and time again that we worry about the implications, the long-term implications of screen time. So one of the concepts, and the way that we do a lot of that work is that we do a lot of, Wizards of Oz and bring kids and bring parents and take these things to schools and try all of these different things to see, what would be actually an interesting approach. So, one of the areas that we've been really pursuing is this notion of an AI agent that can actually watch kids as they do things in the physical environment. Because if you actually go to, say, a kindergarten class, you're not going to see kids sitting behind screens doing everything on PCs, right? You're going to see kids on the rug, on the floor, playing with manipulatives, rods and blocks and all of these things, putting tens and ones together and learning their math and whatever it is that they're doing. So how can you turn, essentially, the AI system to be someone that's supporting the actual learning in the physical environment where this is happening? So, one of the concepts that we have built and have tried in some of the schools is the notion of Oscar, who's actually a teddy bear, who's actually really an AI agent that's multimodal, that can actually watch what's happening. And I'm not really sure why this stopped, because we were supposed to have a video. And the video actually played earlier, but it's not playing for whatever reason today. So anyway, so the idea of it is that Oscar is actually this agent who is in a teddy bear personality, who can actually watch kids as they are performing these different tasks. So think of kids as putting tens and ones and different numbers that Oscar will think about and put these give them based on what their capability is and their learning level. And then they can start to put these things together, and Oscar can actually see what they're doing and guide them as they're doing it. But unfortunately, this would have been the most important thing to actually see visually, because what we really try to do is blend the physical environment and the digital environment together. So you see, the space that actually gets manipulated based on what's actually happening. So if the kid, puts the flower pots in the tens and ones correctly, then you actually see like flowers bloom and the whole space kind of transform. And part of what's interesting about this is that you start to personalize that space, right? And they can start to draw things, on butterflies and things like that, and show it to Oscar, and Oscar, will take it into that digital environment, and you start to see butterflies flying all over the space, and they can start to interact with it, and they can bring it to a place, they can move it somewhere else, they can jump up and down to try to actually make it perform in different ways. So you start to actually see that blend of the physical and the digital environment, and what we saw out of these deployments in schools is that it actually did change quite a bit the engagement level that the kids had with the system. It changed quite a bit, how physically engaged they were, and what kind of the positive sentiment and the social engagement and interaction that they had. So, ultimately, at the end of the day, I think one of the things that we start to think about when we think about this is, you're not really trying to essentially design an application for every problem. What you ultimately want, if this notion of human AI systems is something actually that would come out in the way that you would envision, is that there is a set of capabilities that has to do with understanding humans, understanding human state, being able to interact with humans in different ways, and being able to enable all sorts of developers to put together these interesting solutions and applications based on these set of capabilities. And if you're able to do that, then you kind of transform the way that we think about progressing AI into these spaces in a more compelling way. So maybe with that, am I on time, or am I totally over time with no timer? I'm good? OK, so maybe let me stop here and take questions, because I learned from earlier that If I don't stop, I'm not going to get any questions.
Okay, thank you very much, Professor Nachman, for this very, very nice talk. Now the floor is open for questions. Any question from the audience? Yes. You can use the mic, please.
That's not an easy setup.
Yeah.
Hi, Lama. Thank you for the very nice talk. I wanted to ask, I really like the idea of cooperation between humans and AIs, but what do you think that will actually be implemented, or do you think we are at risk that some policies might push that onto the job-taking side and some influential people are maybe not that interested on the human side of that debate?
I think that's a fantastic question. And in fact, part of what's interesting about doing this research in the real world is that a big part of the research that we do is the social science research of this, right? And we're definitely, on one hand, you could look at this and say, the fact that the design of the system incorporates the human by design reduces some of the fears around, replacing human labor, right? On the other hand, though, people are wary, and that's what we're actually finding out, that, but what happens when I train the AI, right? And what happens, look at the manufacturing example, right? There are concerns around, can this be turned against me, right? Is this now watching me all the time to understand where I'm misperforming, right? So, these systems cannot exist without the social construct that they live in and the policies that they need to live within. But really, I think that the difference here is what we're really trying to enable is thinking about the human as a core part of that solution. And not, when I just think, we were talking about this actually last night, and I'm like, if I think about sustainability, right? If I'm trying to spend all of this energy to train continuously these systems that, are trying to replicate human capability and falling way short of that, right? And we just saw in the presentation this morning that we're actually reaching energy capability of the world, right? Something has to give, right? You have to think of a different approach. So I think it doesn't solve it by just saying there's collaboration, but you have to actually get into what are the things that can actually bring in trust, and what are the policies that you put in these organizations to enable that to happen.
Thank you very much.
Great question.
Thank you for the wonderful talk. I'm looking forward to a future with personalized AI. My question is, because, for example, when parents are raising children, each parent has their own view on how children should be raised. And how do we build AI systems which would take this into account? For example, some parents think that their children should be raised as atheists, be it religion or be it active more in sports. Some others think that they should do, chess or some other activities.
So that's a great question. Another great question. Wow, I was told that you guys ask great questions, and this is definitely a good one. So maybe there's a cop-out answer to this, and maybe there's a bit more thoughtful answer to this. So I think, first of all, where you apply this is very important, right? So if you think about, I would argue, and definitely in the US, I don't know what's happening here, but I would argue that in the US, this debate is very active in human teaching. Forget about AI. Let's put AI aside, right? We're seeing, for example, in the US, a huge uproar around, what are the norms that we think about when we talk about, gender, and what does gender mean, and what does sexual orientation mean? And all of these different things across the country, you have debates about what content goes into school and what teachers actually teach. So on one hand, I would argue that you could argue this is orthogonal to whether it's AI or not. Now, you could argue that, well, if it's AI, and if it's something that a parent has complete control over, right, how would you then go and personalize it? And that's actually an interesting argument, and there's definitely a lot of homeschooling that happens, and there's a lot of work that happens at home where parents have more control over that. I think at the end of the day, no matter what the context is that you're looking at, in almost every field that I look at, personalization is key. It's very hard to think about a cookie-cutter solution. I mean, definitely not for learning, because the whole value proposition of doing AI in education is really more about personalization of education, right? So that's a huge value proposition. So, by definition, I think, what do you personalize? And, again, this is where society norms come into place rather than the technology lack of capability that comes into place. I think one interesting part that I think plays very nicely into this is how do you make the AI system more transparent, right? So that teachers, parents, whoever the power agents are within the system are able to actually understand what the AI system is learning and what it's actually teaching the child. And I think the transparency piece is key to everything that we talk about. So I don't know. That might be a cop-out from your question, but...
Thank you.
We can take the next question.
Hello. Congratulations on the presentation. Very insightful.
Thank you.
And my question is, I would take the idea of the personalization, but applying into the cultural perspective, like different cultures around the world, different challenges, people facing different realities. Which are the constraints on translating machine learning and AI solution from a specific culture to another culture? What are the gaps? What are the levels of solutions? How it could be feasible in the real world application?
That's a good question. Maybe let me take as an example autonomous driving. Perhaps is the most cultural thing that I can think of at this moment, that where AI has been applied, more broadly. So I don't know if you're familiar with Mobileye. Mobileye is actually a company that Intel bought, and today really powers hundreds of millions of cars in terms of assisted driving. And one of the solutions that they have been focused on is, for autonomous driving, is this notion of ensuring, I think it's called responsible safety or something along those lines. RSS, I don't remember what the second S was for. But part of what they were really, so in some sense, there is, what are you doing from a perception perspective, right? And how are you able to actually detect everything that's happening within the AI system and everything? But then what is actually the decision-making that you're making based on that, right? When do you turn? What buffer do you keep? All of that. And the way that they've actually tackled the problem is thought of this as an agent that's actually on top of what's actually happening at the lower level in the AI system. So in some sense, you start to build these as multi-levels with then different inputs into the system that you go and actually negotiate in the different cultures and regulations and everything else that you have. So there's a minimum bar that you need to ensure safety, which is actually the first thing. It's like it will not cause an accident. But then beyond that, what is actually acceptable in a society, right? And that's where you go and then you negotiate that. But to be able to do that, all of these parameters need to be human comprehensible, right? And this is where essentially the transparency of the system is key. So that's one way of solving these, is you don't put everything in the middle of a deep learning network and hope for the best, right? You have to actually design your system in a way where there are different parts of that system, with that in mind from the beginning to be able to get there.
Very interesting. Thank you.
Sure.
We still have several questions.
Great. That's my favorite part of any presentation, because I bore myself when I present, actually.
Thanks a lot for your presentation. My question is, in companies that has been doing the same thing for a long time, a lot of the times when AI discussion comes, it's understood as automating some of the things we do or putting all of our data into a search engine or something like that. My question is, how do you get those large organizations to embrace the full potential of AI, to really think about how we can change how we do things completely via AI and work towards developing those solutions?
OK, so there are, if I want to oversimplify this, there are two ways in my mind to do this, right? One from risk, and the second from opportunity. So in the specific context of this, if you think about it, AI is hitting a wall of adoption because of trust issues, because of worry about ramifications of bad decisions, because of worry about data drifting over time, all sorts of reasons. Like if you think about Intel, a wrong decision sometimes could end up with hundreds of millions of dollars before we even know that there's a problem, right? So, when you try to make these decisions that have these huge ramifications, typically there is a notion of a human in the loop because they're actually concerned about this. And AI has had a very hard time in getting adopted in many type of settings, right? So this is where opportunity comes in. So the way to actually position or pitch this, and the way I was able to pitch this research, I mean, this lab is about 90 people, right? So it's not a small investment, or today it's 90 people. It has grown over time. But the way I was able to pitch this is to actually lay out the opportunity space. Because at the end of the day, it's not just for the good of everything, right? It's like, where is that opportunity space? Does it make business sense? Is there anything to go after there? And what problems are you actually solving? So that's one thing. The second part, which is another hat that I wear at Intel. So as an Intel fellow, I actually drive cross-Intel initiatives, right? And one of the initiatives I drive is actually responsible AI. So there, a lot of what companies are doing today from an internal governance perspective, despite that, yet in the US we don't have, AI regulation yet. But I mean, a lot of companies have taken on, responsible AI and putting in governance structures to ensure that they're developing AI responsibly internally, because of the fact that they are worried from a risk perspective about their reputation and where that might end up going. So, I mean, I would say, there's OK, here's for the good of the world and your reputation and brand and all of that you're doing. And then there's the second is, truly, it is solving problems that cannot be solved in other ways.
Next question.
Thanks a lot for the talk. Probably along the same lines of responsibility. What caught attention is that the software is open source, the one that it was used for Professor Hawking. And so are we going to see more of these kind of humanitarian-based AI use? And how do you compare that to a lot of the gimmicky kind of application that we see right now? Are we heading to a world of many AI applications, and I'm kind of swimming in the sea of AIs? But as we look at here in the simpler world without the AI, we just have maybe an app store for application and people develop there, or maybe an Android store for application people develop there, open source, and it's more simpler. When we go to the AI, it's kind of a sea of confusion, of deep networks and things that are not very understood. So how can you differentiate between these two? Thank you.
So it's interesting that your question about maybe let's talk about this example and then maybe more broadly. So from an assistive computing perspective for people with disabilities, so when Professor Hawking reached out to us, I mean, we're a research lab. Intel doesn't have products in assistive computing, right? You could argue Professor Stephen Hawking is probably one of the most famous people on Earth, right? Yet he was using an outdated system. The first question that I should have asked myself, what the heck? Why is this happening, right? But this is a problem with a lot of the assistive computing world, right? Because if you think about any capabilities that goes into your phone, right, there are a gazillion, billions of devices out there, and that development cost gets amortized over the billions of devices. The problem with assistive computing, by definition, is that, the number of users that can use it is limited, and within people with disabilities, every disability, even within MND and ALS, right, the ways that people can use this is very, very different. So you end up designing a system that works for a few people, right? So it's very hard to kind of go down that path. So when we came in, we looked at this, and we were like, OK, there has to be something that we can use, right? The open source world, and whatever. And there wasn't. There really wasn't. And the problem is, it's very hard, to make something like this happen, and this is why I was so excited about the ability to kind of separate what the specific disease is from the actual main platform, because then you can customize it to different things. But, this took about 3 years of development to get something like this as an open source platform, right? But, once it's out there, then people can actually start to build on it. But the initial cost of doing that and getting into people's homes that need it is really hard, because they have limited capability in the first place to even test out all of these things. So in some sense, I would argue that was probably an unusual case, because Professor Hawking understood the unmet need in the world. And in fact, when we started, he said, I will absolutely partner with you and be a user and a designer and everything of that system, but this has to benefit everybody. Because he was getting emails constantly from people saying, what system do they have? We have loved ones who can't communicate, all of that. So I think in assistive computing, you have a very special case, which the economies of scale don't work for. So honestly, outside, I think the open source world is the way to actually change this. Now, specifically the difference between AI and other applications, in some sense, the constant problem with AI is the fact that it's very hard to continue to adapt things to the different environments that it fit in. And that, in some sense, I would argue for all of you researchers out here, and this is something that is always my call to action whenever I actually go anywhere, is, a lot of people seem to think that by putting a proof of concept out somewhere, that the problem is solved, and now this is the hard research problem, and everything else is engineering. And this cannot be any further from the truth. Because in my opinion, a lot of the research that happens ends up happening once you actually get things into the real world. Because that's when you realize that a lot of the methods that we do don't scale into the real world. And that opens up a lot of interesting research to go back into, which is very different than applications that are not AI-centric, right? Because it's not actually learning from data. You put it out in the world, and it kind of knows how to act, and it will act the same way.
Thanks a lot.
Sure. Are we totally out of time? Yeah. See, I had to get us out of time.
Thank you very much. So you kind of touched upon, so there's two questions. So one of them is kind of from a technical side of things. So how do you go about doing a risk analysis for these kind of systems? You talked about making them more interpretable, but relative to, say, traditional machinery, how much more documentation would you require to really go into the different elements? So that's from one side. From another side, a bit different, is I'm curious if the vision of the future acts as a driver in your research, and if so, how does that look like from your vantage point?
All right, two very good questions. So on the first one, basically the approach that we've taken, and this is actually something that we've started back in 2017, and I formed this cross-Intel group to say, what does responsible AI mean, and what does it mean in the context of Intel, and what do we need to do, right? And really what that looks like, essentially there are kind of three aspects to it, right? One is governance. So what do you do internally, which is really where your question was. But then there is also, this is still very nascent, right? So there is still a lot of development from a research standpoint to actually solve, when people talk about explainability, this is not a solved problem, right, as an example. So let's talk about governance, since your question was about governance. In the governance case, we basically have kind of three things that we've done. One is put together principles which you can think of as a North Star, right? This is really what we're trying to accomplish. That's not necessarily what you were able to accomplish, but this is where we're trying to go, right? Those are like guidelines for where we want to go. Then there is what we call an ethical impact assessment. So think about this as a set of, like an inquiry process with a set of questions in certain areas that engage people in the context of their specific project, right? So, you know, you're doing a project on X, then you start to ask questions and risks in specific areas like privacy, security, safety, transparency and explainability, bias, right? So you're looking at risks in the context of that project and trying to say, well, this is the type of risk that I envision, and as a result, this is the mitigation strategy that I'm going to put in place because of that risk. Because, I mean, there is nothing that's risk-free, right? At the end of the day, it's like risk versus reward. So to give an example, right, if one of the things that you're trying to assess is the bias or the fairness of your system, right? So typically, a big part of the problem in AI systems, and you probably saw a lot of the things around, you know, for example, face detection and people of color, and all sorts of different problems, or, you know, things that are, you know, toxic language and all of that, right? If you're trying to do a bias assessment, a lot of times when people are looking at an accuracy of a system, they look at the average accuracy of a system, right? But if you actually think about where bias seeps in, it's actually at the discrepancy of that bias. If you end up with a face detector that works 98% for a white person and ends up working at 50%, right, for a person of color, even if you're average, because most of these data sets skew, right, in the white space, then, you know, that's a hugely biased system that you cannot. So part of what you do in a risk analysis is to actually do quantitative analysis and look at, for this specific solution, what are the biases that I imagine could happen, and how do I actually quantify that and ensure that that is not happening, and I, you know, figure out the data set, retrain the algorithm, do all of the things that I need to actually make that happen. So the interesting thing about an approach like that is that over time, you build up the competency of everybody in the company. Because the point isn't like somebody's going to hand me something, I'm going to look at it, and I'm say, this is yes, this is no, right? Ultimately, what I'm trying to do is have every person think through these things and continue to improve their competency in these areas. And eventually, that's how you solve the problem, really. Because many of those problems you can't anticipate, and a lot of people are thinking about it. The third part of that puzzle is actually having a multidisciplinary team, which we call the advisory council, that actually looks at that both from like different disciplines, different races, different genders, like all of these, like the council is very diverse, right? And I think sometimes as researchers and as technologists, what we want to do is say, oh, we're going to build a tool that actually automates all of these things. But yes, we have bias check tools, but you actually still need all sorts of disciplines and perspectives to even understand what to look for and what the risk might be. And that's a human function. So that was all your first question. Remind me again what your second question was.
Just your future vision of yeah, how this.
So my future vision of AI is actually what I was really trying to say. I mean, I'm imagining a world where AI and humans can actually communicate and collaborate very effectively, and that we can really bring the best out of those as, you know, building the human capability and making people into superhumans, right, by utilizing AI. Like, that's where I actually see it. Not a world where AI is going to rule the world. Unfortunately, I'm not a very Hollywood person, so that's not where my head usually goes.
Thank you.
All right.
I think this brings our lecture to its end. So I would like to thank you very much, Dr. Lama, for this very interesting keynote lecture. I would also like to thank you all for attending. I would like to mention that we were finally able to play the video.
Oh, you are able to play the video. Okay.
Yeah.
It did work in the rehearsal, so I'm not really sure. Okay, so that's Oscar. And now imagine him on like a wall And what you see, this is one example, right, of a math problem where you have different things that are tens and ones, and kids are actually putting, Oscar is giving them a number, they're actually putting those, and if they do this correctly, then the system starts to change the environment to show that. And here they're like drawing something that then Oscar can look at, pull into that digital environment, make it into like those butterflies that they actually personalized, and then they can start to interact with it. They can make it go away or come to them and so on. You can see them starting to do something like measurement and trying to figure out these measurements in the physical environment, but then they're actually using physical activities to actually get this caterpillar to kind of go into their destination and where they want it to go. And then kind of a cute thing that we were doing is we were trying to make Oscar be in the physical environment, obeying the laws of physics. So it jumps, it lands on boxes, kids can help it do things, go through spaces and so on. So there you go. Thank you for making that happen. Thank you so much. Oh, picture.